ch6p54. If two quantities are equal, are their logarithms also equal? Consider the questions below. Is it true that 4 squared is equal to 2 to the 4th power? Is this a special case, or is a to the power of b always going to be equal to b to the power of a for any values of a and b? Well, first of all, let's go ahead and look at letter A. If I'm saying here 4 to the 2nd power, I know that's really the same thing as 16. That's the value that it really holds there. And then if we have 2 to the 4th power, well, 2 times 2 times 2 times 2 is also going to equal 16. So it's pretty safe to say that yes, we can say that they are equal. The second part, though, says, is that a special case, or can we maybe come up with something else here that doesn't follow the same pattern? So how about, let's try something like 5 squared. Well, 5 squared and our 2 to the 5th, are they going to work? Well, 5 squared, 25. 2 to the 5th is 32. Obviously, because this isn't going to follow that same pattern, what we have above here is just a special case. So we could say this is a special case. Okay, so 5 squared equals 25, 2 to the 5th equals 32. So therefore, we could pretty much say that a to the power of b is not always going to equal b to the power of a. Let's look at letter B. Is log of 4 squared equal to log of 2 to the 4th? How can you be sure? So we say log, remember this is like base 10, but of 4 squared, is it going to be equal to log of 2 to the 4th? Well, as we take this and we look at it, let's simplify these. Log base 10 of 4 squared is going to be like saying the same thing as log of 16. And here, 2 to the 4th was 16, so if we take this and we look at log of 16, obviously these are going to have to equal each other because we have the exact same expression. So, are they equal? Yes. They are equal. Now the next part of it, how can we be sure? Well, you could take it here and you could do a variety of things. Let's type it into our calculator here. First of all, here's what the log of 16 equals, 1.204119983. Let's do the log of 4 squared. And remember, this is log, it's base 10. Let's do 4 to the 2nd power. Oops, how did I miss that there? Let's close it there. We got the log of 4 squared. We get the same value. And then if we want to verify the whole thing, log of 2 to the 4th power, we get the same value again. So how can we verify it? Well, we just verified it on the calculator there. So, yes, those are all equal values. Let's look at letter C. Are the equations x equals 5 and log of x equals log of 5 equivalent? Justify your answer. Well, if I look at my first equation, x equals 5, what's the solution to this? Well, the solution here would be that x has to equal 5 in order for it to be true. Now, if we look at this one over here, we have log of x equals log of 5. What would the solution to this one be? What does x have to be to make this true? Well, it's going to have to be 5. So we could say here, yes, these are equivalent because they have the same solution. All right, let's move on to letter D. Is the equation log of 7 equals log x squared equivalent to the equation 7 equals x squared? How can you be sure? So in this one, kind of follows the same guidelines as letter C here. If we have log of 7, that equals log of x squared. Well, we've got the same base here, so pretty much it's safe to say here that x squared is going to have to equal 7 for that to be true. Well, it's asking if that's equivalent to the equation 7 equals x squared. Well, in this case, yes. We've got, once again, if x squared has to equal 7 there, then when you solve those, you would end up with the same value of x that would have to make it true. So for the same reasons here, we could say that 7 has to equal x squared. So yes, they are equivalent. Now, this one asks, how can we be sure? Well, how can we be sure that those are equivalent to each other? Well, we could figure out our value of x. If we have x squared equals 7, that means that the value of x is going to have to be the square root of 7. So let's take it here. If we want to check it, we could, throw it in the calculator. Let's see what happens. Verify it this way. If I wanted to say, okay, well, the log of 7, there's the value of the log of 7. And if I wanted to take the log of, well, if we had to solve this for x, remember, x would have to end up equaling the square root of 7. So let's do the log of the square root of 7, and let's square it. And we should get the same answer. So that's a great way to verify it there. So we've verified it there. I think that was the last one. Yep. So this is A, B, C, and D there. Yes, these are equivalent. Yes, these ones are equivalent there. Yes, these ones are equal to each other. And up here, the first two are equal, but that's a special case. The rest of the A to the power of B doesn't equal B to the power of A would not work. Just a little recap, little summary over A through D on problem 6-54. If you have questions, make sure you ask your teacher. This is just a little bit of a preview problem for what's coming ahead in the second half of Chapter 6. Thanks for watching.